Morning, everyone. I hear there might be some sore heads out there, so I promise to keep this high level and fairly easy on the brains. So, yeah, today I'm going to talk about Genie, which is our new pipeline orchestration platform, which is powering the newborns generation study for the NHS and Genomics England. So, to get started, a little bit about Genomics England itself. So, Genomics England is an entirely UK government-owned company, which is a bit of a funny setup. So we're not quite part of the civil service, but we're almost entirely funded by the UK government. We were set up in 2013, initially to deliver the 100,000 Genomes project, which many of you may have heard of. This was a project to sequence 100,000 genomes to look at rare disease and cancer patients and figure out if there was useful information in the genome that could be used in routine care. In 2018, we reached the goal of sequencing 100,000 rare disease and cancer genomes in conjunction with the NHS, and proved the value of continuing with whole genome sequencing. So in 2020, we're commissioned to deliver the first whole genome analysis as part of the NHS's Genomic Medicine Service, which we have continued running to this day. And in 2021, a series of new exciting projects were announced under UK government funding, including the newborns generation study, to give it its proper name, Cancer 2.0, which looks at using various novel techniques in cancer analysis, such as long-reads analysis, and the diverse data cohort, which looks at improving the diversity of genomic data sets. So, to dive into the meat of today's talk, so I'd like to start with two real-world patient stories from the 100,000 Genomes project. So firstly, Owen's story. Now, Owen was born a healthy baby, but unfortunately around the age of 1, he started developing concerning symptoms. So he was having trouble sitting up properly. He was also having trouble crawling around. So his parents took him to the doctor. He went to various specialists, and after about 3.5 years, eventually his genome was sent for sequencing. It came back that unfortunately he did have a rare congenital disorder with his thyroid gland. But thankfully, there was a really easy treatment pathway that he could then be put on. And very quickly, Owen amazingly made some really good progress and is now living a normal, healthy life, which is a really good thing to hear. But wouldn't it have been amazing if we could have figured that out sooner and got him on the right treatment pathway earlier, avoided all that pain of that long 3.5-year diagnostic odyssey? Secondly, Nala and Teddy. So Nala and Teddy are sisters. Nala's on the left here, a few years older than Teddy. Unfortunately, around Nala's second birthday, she started developing some issues with her sight and hearing. She was taken to various specialists, eventually had an MRI scan done, and it turned out that she had a rare disease called metachromatic leukodystrophy, or MLD. Unfortunately, once you're symptomatic, there's not much that can be done, and it does lead to a progressive loss of most senses, motor control, and ultimately it is fatal. Now, thankfully for Teddy, her younger sister, because Nala had been diagnosed with MLD, the doctors determined that there was a 25% chance that Teddy may have inherited this as well. So Teddy's genome was sent off for analysis. Unfortunately, she had inherited the faulty gene, but because we'd identified it before the symptoms started occurring, she was able to be put on a novel gene therapy called Libmeldy and is now living a full and healthy life. But wouldn't it have been amazing if we could have done that earlier and also done that for Nala too and helped Nala? So what this kind of brings into the fore is the concept of the diagnostic odyssey. So this is how things work today. A baby's born, they may develop symptoms. At that point, they're taken to the doctor, they go to various specialists. They might undergo various tests, and this whole process can take months, possibly even years, and they may get a diagnosis at the end of that. But unfortunately, over this whole time, that child is living with whatever condition they've developed. What the newborns generation study aims to do is to skip out those middle steps, and it moves to a much more proactive and preventative form of medicine. So the idea is to recruit mothers who are willing to take part in this over the next 3 years, with the aim of sequencing another 100,000 newborns here, and sequence their genome shortly after birth looking for a list of around 200 conditions where we have quite good confidence that there's a good treatment pathway available, and that if we intervened, we could vastly improve the life of that newborn baby. So yeah, this is the idea of the Newborn Generation Study. You might be asking how this is relevant to a conference on Nextflow. Well, my team are tasked with the challenge of building a system to automatically and continuously process 100,000, again, we seem to like this 100,000 number at GEL, whole newborn genomes over a period of about 3 years. So initially, we looked internally. We've had plenty of experience in doing this sort of continuous automated genome processing in the past, as mentioned. We have this tool, which was built back in 2014 initially, called Bertha, named after an 80s children's TV character, which is a machine that could produce anything that you asked of it, whilst encountering various difficulties along the way, which I think is a very apt name for our experience of Bertha. It's a registered medical device, and it's done an amazing job of powering the 100,000 Genomes project and continuing to support the live clinical service, the genomics medicine service, or at least the whole genome sequencing part of that. However, Bertha was determined to not be suitable to continue, to start running the Newborns Generation Study as well. Unfortunately, being a system that's over 10 years old and was built in-house, and let's cast our mind back to 10 years ago, things like Nextflow were very much in their infancy, so that's partly why the decision was made to do it in-house. But the problem is that it was built very much for that 100,000 Genomes project research study at the time. It was never really built to be adaptable to new use cases. So first of all, kind of unpicking that hard wiring in Bertha was going to be a bit difficult for newborns. It doesn't make use of the latest industry standard tools, such as Nextflow. So that means that when people come into Genomics England, they have this kind of very esoteric, built from the ground up system to learn. They can't take all of that learning that they've got from their degrees or from previous companies. And also, we can't take advantage of the community here today and NF Core, NF Test, etc., all of the kind of great work that the community does. So we wanted to be able to take advantage of that. It's not really scalable to meet future capacity requirements, so we had concerns over adding this extra load to Bertha. And then kind of related to that, we want to be able to run workloads on the cloud easily, not just for capacity reasons, but also for disaster recovery, because we have some quite strict service level agreements that we need to meet with the NHS. So we decided to build a new system called Genie, and the idea is that Genie will do all of these things. So next, I'll go into a little bit about what exactly Genie is and what it does. So at a high level, it's a fairly simple orchestration system. It's designed to continuously process genomes as they come in. So genomic data is delivered to Genomics England by Illumina. The first thing that we do is kick off a workflow which checks the quality of that data. That runs on a standard CPU, and it's a Nextflow workflow, as you'll notice. The next thing is that we run the second workflow, which is mapping and variant calling. This runs on specialist FPGA compute. And then once clinical data is available, we run the final workflow, which is variant prioritization, which tells us which variants might be of concern for this baby. And that runs on standard CPU. The last thing that's done, results are dispatched, and then a clinician interprets those results and sees if further treatment is required. So yeah, you'll notice that all of these workflows are built on Nextflow. I won't go into too much detail on the workflows today, but I can refer you back to last year's Summit's talk, which is available on the YouTube channel, where a few of my colleagues talked in detail about the migration approach of picking up these Bertha workflows and putting them into a Nextflow language. So a little bit more about how Genie works specifically. Essentially, what we've tried to do with Genie is build an orchestration system that, in response to any event, can launch any Nextflow workflow on any compute environment. So kind of walking you through the process. Initially, an event occurs. This might be that genomic data has been delivered. It might be that a previous workflow completes. It could be anything. It could be that the washing machine's completed its spin cycle. Any event, we want to be able to launch a Nextflow workflow after receiving it. The next thing that happens is that we figure out, okay, now this event has happened, which specific workflow do we need to launch in response to that? So we've built using kind of AWS standard services such as lambdas and step functions, an orchestration engine that's able to determine that and where to run that workflow as well. Bringing in Seqera, so that sends a launch workflow request to the Seqera platform. Seqera picks the Nextflow workflow that's been chosen, and then that's scheduled on the compute environment of choice. So I think it's worth mentioning that this sequence of steps here is made so much easier by both the fact that we've moved those workflows to Nextflow, so they can be soon running in multiple different compute environments, and also the Seqera platform makes it very easy to plug into those different compute environments. However, we are actually not quite ready to support batch just yet. So the final thing that happens is that when the workflow completes, a new event is raised, and that event will then come back and Genie will determine, okay, now do I need to do something else, or is this pipeline complete for this patient? So where are we today? Some of you might have seen just a few weeks ago in the news now, it made headlines that the Newborns Generation Study has officially launched. So we are now at the point of having recruited over 1,500 mothers, which is really, really exciting, and already have processed about 300 newborn genomes through our system. You can see a screenshot here of some of those genomes happily processing through the Seqera platform. Lots of green there, which is what we like to see. Out of those 300, there's been a handful of positive cases identified. So the next step is for a clinician to review those and potentially put those babies onto the correct treatment pathway to hopefully avoid the sorts of diagnostic odysseys that we saw with Owen, Teddy, and Nala. And it'd be amazing. I really hope to be able to come back next year and give you some updated case studies around some of the lives that we've been able to positively impact through this study. So briefly, where next for Genie? So the first thing, Newborns Generation Study ramp up. So the recruitment of mothers is very much on an exponential curve at the moment. It can take up to 9 months between recruitment and before we get a newborn genome sample in, for obvious reasons. So we expect what starts with a bit of a trickle to become a bit of a flood over the next few months. So we're getting ready for that. The second thing, I don't know what's happened there. That's not the emoji that I chose. Anyway, we will switch the whole of the NHS's genomic medicine service for whole genomes over from Bertha to Genie. And then what we'll be able to do is switch off Bertha once and for all. At that point, we'll be in a state where we're only running Nextflow workflows, and we can start to refactor them to be Nextflow native. We can then support hybrid data processing and storage. And I don't have time to go into them today, but there's many, many exciting future use cases that we want to support across Genomics England as well. So having Genie and the flexibility to do that should help us get there in the future. Thank you.
Oh, thank you. That was fascinating. And there's a ton of questions on Slack. Okay. So I have the difficult job of picking only a couple. Can you talk to what the plan is for how the data will be used in the future? Now you have these babies' genomes. Are they going to be kept? Is there a plan for how to manage the ethics and the logistics of storage, all of that?
Yeah, so I mean, at the moment it's a 3-year pilot project. The aim is to do about 100,000 newborns over that period. But part of that pilot project is answering some of those really thorny questions. So we have a full ethics team who are looking at some of the ethical questions. I mean, one of the things that people often ask is, well, you know, if you could figure out that somebody at age 40 is going to develop some sort of disease which only comes on at 40, such as Huntington's, well, the idea is with that list of 200 diseases that we look for, we're just limiting it down to looking at the things that we think we can impact in the first few weeks and months of life. But yeah, in terms of the data long term, so when parents sign up, they consent whether to have, and this is the case with patients coming through the Genomics Medicine Service as well, they can consent to have those genomes used for research purposes as well. Mm-hmm. About 90% of people do tick, yes, I'm happy. And then there's a whole other side to Genomics England that I haven't discussed today, which is our research environment, where those genomes are made available to academic and clinical researchers. At
what point does the child who eventually grows up get to choose whether their genome keeps getting used for research or not? Is there a plan for that?
It's a good question. I could guess at the answer, but what I'll do is I'll take it away and go and ask the team to get something.
Fair enough. Absolutely. And from a technical standpoint, can you talk a tiny bit more about you said when an event happens, say a workflow completes, another workflow gets kicked off. Can you say a tiny bit more about how that works?
So I mean, the events are taken on AWS Event Bridge. We have a series of lambdas which then pick up those events, and based on various kind of orchestration logic, which is the idea is for that to be very easy to configure to different use cases, that will then launch the right workflow in response to that event. Once that workflow completes, an event goes back, it says this workflow is completed. The orchestration logic might then say, okay, you need to kick off this next workflow, but have you then checked if this data is also available? So yeah, it's all essentially done through a series of lambdas and AWS native tools.
A lot of people are interested in doing that sort of thing. Is that part of the methodology public and open source? Can somebody else do the same thing you did?
It's not open source at the moment. That is an ongoing debate within Genomics England at the moment, so we might see more about it in the future.
Interesting. All right, well, thank you very much. It was fascinating. Thank you.
Thank you.